You all, I am Dr. B. Lakshmi, Head and Assistant Professor of Physics, Trinity College for Women, Namakkal. Today we are going to know about UJT. UJT is nothing but Uni Junction Transistor. The Uni Junction Transistor is a three-terminal silicon semiconductor device. The UJT has only one PN junction like an ordinary diode. It consists of N-type silicon semiconductor bar and P-type silicon region. The N-type bar is called base and P-type region is called as emitter. The PN junction is formed between emitter and base region. The emitter region is heavily doped compared to the base region. So, the resistivity of base material is very high. Three terminals are taken from this structure, one from emitter region and two from the base region. There are base 2, emitter, base 1. The emitter region is closer to base 2 terminal than base 1. Symbol of UJT. The schematic symbol of UJT is different from junction field effect transistor. The difference is that the arrow is at some angle in the schematic symbol of UJT. UJT LED identification. UJT LEDs is identified in clockwise rotation from tab, emitter, base 1 and base 2. Equivalent circuit of UJT. It consists of diode and resistance. The diode represents PN junction, while the resistance RBB is the internal bulk resistance of silicon bar from one end to the other. Here, RBB is the total resistance between the base terminal and it is also called inter-base resistance. RB1 is the bulk resistance between emitter and base 1 terminal. RB2 is the bulk resistance between emitter and base 2 terminal. So the value of RBB is sum of RB1 and RB2. Next one is intrinsic standoff ratio. Consider the equivalent circuit of Uni Junction Transistor with a battery VBB applied across the base terminal. As the emitter is open, the applied voltage divides across the resistance RB1 and RB2. So the voltage drop across the resistance RB1 is VA is equal to VBB into RB1 by RB1 plus RB2. So the value of VA is equal to eta into VBB. Here, eta is known as intrinsic standoff ratio. This value is always less than 1. UJT operation. The voltage VBB and VEE are connected with the equivalent circuit of UJT. The emitter diode is reverse biased by a voltage drop across the resistance RB1 and its own barrier potential, that is VD. The total reverse bias voltage across the diode is equal to sum of eta VBB and VD. The emitter voltage is below the total reverse bias voltage across the diode remains reverse biased and there is no emitter current. The applied voltage reaches the value is equal to eta VBB plus VD. The diode conducts and emitter current flows. The value of emitter voltage which causes the diode to conduct is called peak point voltage. That is Vp is equal to eta VBB and VD. Under this condition, UJT is said to be fired or triggered or turned on. As a result of this, the emitter current increases while the voltage at the emitter decreases. It produces a negative resistance region in the VI characteristic of UJT. Here is the characteristic of UJT. The curve between emitter voltage and emitter current of UJT at a given voltage VBB between the base. This is known as emitter characteristic of UJT. Here we consider two important points on the curve, peak point and valley point. These 2 points divides the curve into three regions, cutoff region, negative resistance region, and third one is the saturation region. Cutoff region is nothing but left of peak point voltage. The emitter voltage is below the peak point voltage and emitter current is approximately 0. Here UJT is in off position. Second one is the negative resistance region. This is the region between peak point and valley point. The emitter voltage decreases from Vp to Vv and emitter current increases from Ip to Iv. The increasing emitter current is due to decreasing the resistance Rb1. The UJT is operated as an oscillator in this region. Third one is the saturation region. This is the region beyond the valley point. The UJT is in on position. The emitter voltage is almost constant with increasing emitter current. Advantages of UJT is low cost device, excellent characteristic, low power absorbing device under normal operating condition. Applications: trigger device for SCR and triox, non-sinusoidal oscillator, a sawtooth generator, phase control and timing circuits. Thank you all.